So look at this problem right here. Again, we have a rational expression, but notice how it's not set to zero. So we still got set to zero before we can even do anything. So again, the inequality must be set to zero for us to use our strategy that we've been using. So we're going to move this over. I'm going to go ahead and do this down here. X plus 19 over X minus 14. And then when the 1 comes over, it's going to be a minus 1 is now less than or equal to 0. So that's one of the first times we actually have less than or equal to in there. So one of the things we want to do is to make this all work, this has got to be all under the same fraction. It's got to be all under the same denominator. I've got like two pieces now. So one of the things I got to do is I got to get this 1 combined in with this. So remember, to add fractions, we have to have a common denominator. Since this denominator is x minus 14, this has got to have a denominator x minus 14. But you also got to change the top to an x minus 14 as well to make it equal to 1. So essentially what happens here is that we have this x plus 19 over then this x minus 14. And we're going to be subtracting then this x minus 14 over this x minus 14, if you will. Now, the reason I put the numerator in parentheses is to remind me that this whole numerator's got to be subtracted. But notice how x minus 14 over x minus 14 does represent 1. But since we do have a common denominator, we can combine the numerators together. So I have this x plus 19. The subtraction sign is going to go through. That's going to make that a negative x. And then this negative 14 is going to turn into a positive 14. And then this is going to be over then x minus 14 is less than or equal to 0. So notice how the x and the negative x are going to zero out. 19 plus 14 would be like 33, I believe. That's going to be x minus 14 on the bottom is less than or equal to 0. So let's double check ourselves on the math there. Does 19 plus 14, does that give me 33? Yeah. So now we've got it set. Now the catch is we want to find the zeros and the domain exclusion. So we want to find the 0 of the numerator, but notice that the numerator cannot be set to 0 because it's a number, it's not a variable. So the numerator will never be 0. So I can't make a 0 there. So, but I can find a domain exclusion. So what I can do is set the x minus 14 equal to 0 and x equals 14. But remember, that's a domain exclusion. We can't include it at all. So we can't use 14 at all because if it do, it's going to make the denominator 0. So when we make our number line, all we have is one critical value, which is the 14, and we can't include it. So what I have to do is look what happens to the left of 14, look what happens to the right of 14. So again, I'm going to put this function in here, this 33 over x minus 14 into the calculator. So y equals then, if we clear that, 33 divided by, in parentheses, x minus 14. So the parentheses make sure that includes that as the whole denominator. So if I go to the table, what we're looking for is that 14. Notice that 14 gives me that error. Now, if I go left of 14, notice that I'm getting negative values. It looks like it stays negative as well. So there's no other sign change. So these are all negative over here. Now, if I go to the right of 14, notice that we do get positive values. So there was a sign change there. So notice how, since the degree of the numerator is smaller than the degree of the denominator, remember, if the degree of the denominator has a bigger degree, the horizontal isotope is going to be y equals 0. So if I look at it from a graph perspective, we're kind of seeing that graph there, but we're not seeing the full picture because the vertical asymptote is at 14. So if I hit the window and change x max to maybe go out to, say, 28 or 30 or so, if I do that, I may want to not go so far left. Let's change it back to maybe a negative 10. If I go by 2s, that don't look like that's going to be too bad. So if we now graph it, you can kind of see that half the graph is below the x-axis and half the graph is above the x-axis. And out there is where that 14 is, 2, 4, 6, 8, 10, 12, 14. That 14 is about there. So notice that if you go right of 14, the graph's above the x-axis. That's why we have these positive values over here. If you go left of 14, the graph remains below the x-axis. Because remember, since the degree of the denominator is bigger, y equals 0 becomes a boundary line. So this graph cannot go below the x-axis on the right side. And this graph here can't go above the x-axis on this left side. It's got to stay below. So it's kind of matching what we're thinking as far as our solution goes. So it looks like our solution is going to be to the right of 14. And again, since it's a domain restriction, we cannot include it. So we use a parenthesis there. 14 to infinity would be our solution for that rational inequality.